With DoubtNet, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download DoubtNet app today.
Hello everyone, let us start with our question. In this question, what is given that there are two identical balls AB, each of mass 0.1 kg, and they are attached to one of the identical massless spring. Now the spring mass system is constrained to move inside a right smooth pipe bent in the form of circle as shown in the figure. The pipe is fixed on a horizontal plane and the center of the ball can move in a circle of radius 0.06 meter. Now basically this is our pipe. It is bent in the form of a circle and there are two balls A and B. Now these are connected by massless spring. Now they are constrained to move only inside this circle itself. Radius is given as to be 0.06 and the natural length is given as to be 0.06 meter for each spring. For each this spring, this natural length is 0.06 pi meters, and for this spring also it is 0.06 pi meter. Force constant value, that is the K value, is given as to be 0.1 Newton per meter. Now initially both are displaced by an angle of pi by 6 radian with respect to the diameter PQ of the circle and then release. That means this was its initial position. These were the initial position of the spring. Now we have taken it to A to this position and B to this position. Now this is basically a symmetric position because here also this is pi by 6, here also it is pi by 6. Now the mass is also same. Mass for this, mass of this, these are basically also same. Now and then they are released from the rest. So this is the rest situation. That means velocity here would be equals to 0 for both the cases. We need to find what is the frequency of the oscillation of the ball A. So in the A part, basically these are identical springs. So this frequency for A and B there, that would be exactly same. Now how to get the value of the frequency? Frequency would be equals to 1 divided by time period. Now what is time period? So whenever there is a for example, there are two masses and there are two springs. So we use this equivalent concept to calculate the time period. How to calculate time period? We write 2 pi. Time period would be equals to 2 pi mu divided by K equivalent. Where mu is what? Mu is the reduced mass. Whenever there are 2 or 3 masses, we use this time period like this. We calculate time period like this. So mu value would be equals to m1 m2 divided by m1 plus m2. What is m1 m2 divided by m1 plus m2? These are the masses. Though in this condition masses are given as to be same. So m1 would be equals to m2 would be equals to m. So we can just write m square divided by 2m. So it would be m divided by 2. Now what is the mass? Mass is given as to be 0.1 kg. So it would be 0.1 divided by 2 kg. So this would be 0.05 kg. So this is the reduced mass which we can put here. Now what would be the K equivalent? K equivalent. Now the two spring here, these are connected in parallel. So for the parallel case, what is the K equivalent? It is basically the sum of the two spring constant, K1 plus K2. Now here also the spring are basically same. So we can say that our K equivalent would be equals to 2 times of K. Because K is same for both the spring and K is given as to be 0.1. So this would be 2 into 0.1. That means 0.2 Newton per meter. Now if we put the values, so our time period would be T would be equals to 2 pi. In the square root, it would be mu value 0.05 divided by K 0.2. If we calculate this, then it would turn out to be 2 pi, and this factor would be equals to, after coming from the square root, it would be equals to 0.5. So it would be coming in the square root, it would be 0.25. If we take the square root, it would be 0.5. So this would be equals to pi. So what is our frequency? Frequency would be equals to 1 divided by time period. Now time period is pi, so frequency would be 1 divided by pi hertz. Hertz or per second. So we have calculated the first part. Now in the second part, we need to find what is the total energy of the system. Now in the total energy, what would be the total energy? So we are just pulling it like this. So this is placed on the horizontal table. So it is not like that it is raised from a height. It is placed on the horizontal table. So height would be same. So there is no potential energy due to gravitation. So it is not having any velocity. So no kinetic energy. So what is the energy which is it's holding? It would be just the this spring potential energy. So we can say that spring potential energy in the B part, total energy E would be equals to spring potential energy U. So it would be equals to 1 divided by 2 K1 x1 square plus 1 divided by 2 K2 x2 square. Now K1 and K2 basically these are same. Now we can see what is x here. X is basically elongation or compression. Whether it is elongation or whether it is compression, we can put the values because it is a square. Even though if we put the negative sign, so it would be just a square. Now here we can see that the elongation of this spring. So this was the mean position. We are elongating this spring. This whole spring we are elongated from certain distance. Let's say, let's assume the distance to be s. In this case, s in this case. So what is the total elongation? X. It would be equals to 2s in this case. Okay. Now this would be same as the compression of this spring. Why? Because they are connected together. The balls are connected together. So the elongation of one would be equals to the compression of another. So we can say that our x1 would be equals to x2. Okay, one would be elongation and one would be compression, but magnitude wise they would be same. Now spring constant is also same, elongation is also same. So we can say that our total energy would be equals to 2 times of 1 divided by 2 k into x square. Okay, now what would be the value of x? We can see from the figure itself. What is this part? This is basically arc. How can we write the value of s, which is equals to arc? Arc is basically, s would be equals to, arc is angle, which is equals to pi by 6 multiplied by radius. This is how we write the arc. Now we know the radius, it is 0.06. We can just substitute the values. So if we put the values, 2 would be gone. So k value we know 0.1 into x is 2 times s. S is what? Pi divided by 6. This is our angle multiplied by the radius. Radius is 0.06. So 0.06 is square of this number. So our E would turn out to be, E, if we calculate, this is the total energy, it would be equals to 4 pi square into 10 raised to the power minus 5 joule. This would be our energy. Now in the C part, what we need to do? In the C part, we have calculated this. In the C part, we need to find the speed when A and B are to the end of the diameter PQ. That means when they are coming back to its natural position. Now at this natural position, so the total potential energy which they have gained, so they would be losing the potential energy here. Why? Because they are coming to the their natural length. So where is the potential energy going? So potential energy would be going into the kinetic energy. That means it would be converted into the kinetic energy. Now due to symmetry, the kinetic energy, because mass is also the same and the angle to which they have moved, this is also the same. So the kinetic energy of A would be same as the kinetic energy of B. Okay, and it would be equals to the total energy at this level. So we can say that kinetic energy would be equals to our total energy. Okay, or we can say that potential energy at that location pi by 6. So what would be the value of kinetic energy? Just 2 multiplied by half mv square, because due to symmetry mass is same, velocity would be same, and because due to the angle which is same for both the cases, and this would be equals to E, which is equals to 4 pi square 10 raised to the power minus 5. Now this 2 would be gone. Then our v square would be equals to 4 pi square into 10 raised to the power minus 5 divided by mass. Mass value is 0.1. We can put the value as 0.1. So our v square would turn out to be, so v square in this condition would be 4 pi square into 1 power would be reduced 10 raised to the power minus 4. Now if we calculate v would turn out to be 2 pi into 10 raised to the power minus 2 meter per second. So this is our last part. So we have calculated the velocity. This is our velocity. Okay, we have calculated the total energy in this part, and also we have calculated the value of the frequency, which is coming out to be 1 by pi hertz. So we have calculated both the three parts. Okay, hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.